All right, today we're going to look at complex fractions. So as you can see, we have a numerator that involves subtraction and a denominator that involves addition of fractions. To simplify complex fractions, we're going to combine addition and subtraction with our multiplication and division. So for this first problem here in your notes, you want to look at just the numerator. The 17 twelfths minus 1/6. You want to subtract these fractions. So you're going to need a common denominator. The LCD between 12 and 6 is 12, so you'd multiply that second fraction by 2 over 2. And we now have 7/12 minus our converted fraction 2/12, which would give us 5/12. You're going to do the same thing for the denominator. We have 2 plus 4/9. So you need a common denominator, which would be 9. So the 2 you would have to multiply by 9 over 9, and then combine it with the 4/9 to get 22/9. Your goal is to have a single fraction divided by a single fraction, because we can rewrite that. You've done a bunch of problems like this now. We have a fraction divided by a fraction. Next is our same change flip. And you can cross-reduce. The cross-reducing makes a little more sense when we have variables, but you can also cross-reduce with numbers or multiply them and ultimately reduce it. So pause if you need to get caught up or to listen again, but that is example 1. For example 2, it's going to be the same process even though you're involving variables. We have a numerator divided by a denominator. So for your numerator, we're looking at c minus 1 over c. The common denominator would be c. So when you multiply that first fraction by c over c, it's going to end up being c squared over c. Create your singular fraction, and then hopefully you remember from addition and subtraction, you want to factor in order to simplify. So your last step is to factor as much as possible. We're going to do the same thing in the denominator. 1 minus 1 over c. Your common denominator is c, so the 1 we're going to rewrite as c over c. Combine into one fraction. Now once you add or subtract, you want to factor in order to simplify. This one, though, does not factor. So then write out your division problem. C plus 1 times c minus 1 over c divided by c minus 1 over c. You're going to keep your top fraction the same, change to multiplication, and flip your second fraction. Now here's where the cross-reducing should make a little more sense. You can cancel your factors of c minus 1, and you can cancel your factors of c to ultimately leave us with c plus 1. Again, pause here if you need to, and try this one. All right, the next one, we're going to do the exact same thing. And I really want you to think about this one. If you had a problem that looked exactly like this, we now have a binomial with negative exponents. How would you rewrite that binomial? Well, hopefully you said something like this. X would need to move to the denominator, and so would y. That's true for not only the numerator, but the denominator as well with those negative exponents. Write your fractions separately, but keep them where they belong. That binomial is in the numerator. Keep it in the numerator, even though those negative exponents form a denominator. Then it's that same process. Get a common denominator. In the numerator, it's xy, so we would end up with y minus x. In the denominator, it's x squared y squared, so we would end up with y squared minus x squared over x squared y squared. Now, I did this all in one step. You might need to write this out a little bit more, but you need to same, change, flip, and factor anything you can. Okay, it is the same steps we use for addition and subtraction, where you need a common denominator, combine like terms, then factor. We're now adding in at the end, we're multiplying. by creating a same change flip problem from division. You then can simplify it further by crossing out your common factors. That would be your y minus x with your y minus x, and xy with one factor of x, one factor of y, leaving you with xy in the numerator and y plus x in the denominator.